So the first thing I asked you to do was to use this interactive app to just find some notation for the permutations that would turn the word post, P-O-S-T, into each of these four words. And so here are the results that we got up here. So any one of these combinations of cycles, so we call each one of these little things inside parentheses a cycle. So 1-4 would be a cycle. 1-4-3 is a cycle. 3-4 is a cycle. I stick cycles together, and I call those permutations. Right? So compositions of cycles, we call those permutations. And because the effect of each of these combinations of cycles, each of these permutations, is the same on the word post, it turns it into pots, this product of elements is equal to this element, which is equal to this product of elements. By the way, take the second equation for a moment. 3-4 is equal to 3-4, 2-3, 2-3. What does that tell me about the element 2-3? This is like saying x is equal to x, y, y. What is that?
Inverse of itself.
2-3 looks like it's the inverse of itself. Okay, so hang on to that for a moment. These permutations are all equal. These permutations are all equal. These permutations are all equal. But they don't seem to be equal one to another, right? Like one of the ones on this row is not equal to one of the ones on that row because the effect on the word post is different for each of these two. One piece of advice that I want to get right out front here, when we talk about question 2, how do these elements work? And the advice here is don't confuse the letters with the numbers. So what did your group say about how this notation works? What are these cycles doing? What are they telling you to do to these symbols, S-T-O-P? Caitlin.
So they're telling you?
So observation number 1, coming from the diamonds group, is that taking the notation 1, 3, 2, 4, what it can tell us to do is take this last pair, 2, 4, and flip-flop those, right? And what we then get is PTSO. Then take the next pair and flip-flop those, 2, 3. That's going to give me PSTO. And then take the last pair, 1 and 3, flip those, TSPO. So here's a question. Does that tell me anything about what 1, 3, 2, 4 is equal to? So in this last column, I asked you to use only the top row keys to do your permutations. How could I write 1, 3, 2, 4 using just the top row keys? According to this. 2, 4, then 2, 3, then 1, 3. Well, how would I write that? I'd write it as this. 2, 4, then 2, 3, then 1, 3. Right. Should probably check and make sure that this is actually accurate. Press those keys. So that's one way of looking at it, right? Is looking at what we just accomplished. This is something we do want to hang on to. What we just accomplished is we've rewritten this permutation as a product of what we call 2 cycles. Cycles of length 2. What are these cycles of length 2 doing? They're just transposing. They're flip-flopping 2 of the positions. We call those transpositions. Did any other group, before we wrap up, come up with a different interpretation for how to understand this cycle notation? Yeah. So there's another way to decompose this cycle. You could first switch 1 with 3, and then switch 1 with 2, and then switch 1 with 4, which I would, again, write from right to left, 1, 3, followed by 1, 2, followed by 1, 4. Is that what you had, yes? Right. So there's actually a couple of different ways to rewrite this as a product of transpositions. And whichever way you see it, they're going to give you the same permutation at the end of the day. Let me give you one more, or maybe I'll ask, is there one more interpretation of how this works that your groups found that we can wrap up on? Because this turns us to TPSO, right? We decided? Or no, TSPO, right? So did any other group have a different interpretation? Maybe just, let me give you a clue here. What's happening to the letter P?
It looks like everything's shifted 2 positions.
Everything's shifted 2 positions. So the thing that started in position 1 ends up in position 3. So I have 1 goes to 3. But then the thing that was in position 3 is S. Where does the S end up? Position 2. And that accounts for this 2 here. And then the thing that was in position 2, O, ends up where? Position 4. And the thing that was in position 4 ends up back in position 1. So another way to read this, and this is why we call these cycles, is that as you read this cycle from left to right, it's telling me what position goes to what position. 1 lands in 3, 3 lands in 2, 2 lands in 4. And at the end of the cycle, 4 lands back at 1.